Our children are the future. Our future. What will we pass down to the next generations? We always assume their world will be better than ours, but that will depend on us. Will the world we leave them be a healthy world, or will we leave our children an environment so polluted it actually hurts their quality of life? How will we answer the question of legacy? This year, the United States will generate over 250 million tons of municipal solid waste. This is enough trash to cover Washington, D.C. 20 feet deep every single year. We're creating it faster than we can dispose of it. Not only does it generate methane and CO2, both very potent greenhouse gases, it's also a primary cause of many other forms of pollution. And the growth of economies and populations worldwide will cause this problem to grow worse on an exponential level. Dr. Nicholas Themeles is a renowned waste-to-energy expert and professor emeritus at Columbia University.
Well, good morning, everyone. On behalf of the...
He recently hosted an environmental debate in New York City. The opposing sides agreed. The impact of waste disposal is a critical issue, and this kind of dialogue is happening all over our nation. The public is concerned, and intelligent use of our resources is on the front page. President Bush, Al Gore, Governor Schwarzenegger, Mayor Michael Bloomberg, the United Nations, even Wall Street, all concerned, and all based on proof released by top-level scientists that global warming is a reality. Garbage has gone mainstream. And it's a good thing it has. The National Academy of Sciences. We surpassed the regenerative capacity of the planet around 1980, pushing its biological systems beyond their ability to heal. Options: composting, recycling, both a great start. But with the U.S. currently recycling 20% of its waste and composting another 9%, we're leaving fully 71% to be disposed of either by incineration or landfill. Incineration is far less toxic than it once was. It processes waste, generates electricity, but generates 1 ton of ash for every 4 tons of waste it processes. This ash must then be placed in landfills. There are landfills across our nation dedicated only to the ash from incineration. Landfill is dangerous at best. Waste takes decades to break down, and the liquid runoff poisons our groundwater, streams, and rivers. Often overlooked, people assume that if they don't live close to a landfill, they are not affected by a landfill. Dr. Themeles.
From a global point of view, let's say from the global atmosphere, no matter where you put landfills, you have to deal with the greenhouse gases that are emitted from them. And this is due to the methane.
Methane, which is 21 times more potent than CO2. No matter where we locate them, rotting landfills remain a primary source of these 2 greenhouse gases. And transporting the garbage from neighborhoods to distant landfills creates another serious problem. Long-haul garbage trucks put tons of diesel fumes into our air. Incredibly, garbage is often swapped state to state. Waste from Texas headed for Louisiana often passes waste from Louisiana headed for Texas. Research from the University of Columbia shows us this situation occurs regularly around our nation, both wasting energy and pointlessly polluting our air. Looking forward, we are depleting our renewable resources. International Institute for Environment and Development. We will mine the world's last tin, copper, lead, and silver in less than 40 years. For many Americans, it's an out-of-sight, out-of-mind situation. We toss something under the sink, take it out to the street, in our heads, it's gone. But in reality, it's simply somewhere else. Traditional waste-to-energy plants create ash, and landfills bury potential energy, untapped resources, and pollute our living space in the process. Meanwhile, our children wait. They expect safety and deserve security. Will we deliver? If we don't act, our children will be raised in an unhealthy world. As responsible stewards of their future, We must find a way to solve the problem of waste disposal without damaging their environment. Done. For over a decade, working in close collaboration with waste-to-energy experts, our team has developed a revolution. It can completely eliminate waste with no toxic emissions. Hard to believe? Let's make it more interesting. This closed-loop, high-temperature gasification process uses ThermoSelect technology and transforms municipal solid waste into clean energy and recyclable materials, again with zero toxic emissions. We have answered the question of legacy today. How? Gasification. Earth's core is molten rock. The high heat and intense pressure combine to create natural gas. Gasification. But zero toxic emissions? Junior high school science. Combustion requires spark, fuel, and air. Without all three, no combustion. Where there isn't fire, there isn't smoke or emissions. Because we carefully control the oxygen levels, assuring there are no emissions. Using ThermoSelect technology, we transform the energy content of waste into synthetic gas, syngas for short, from which we can make clean energy. The solid parts of the waste become commercially useful products. Nothing remains to further clog landfills. And it isn't just theory, it's fact. Dr. Themeles on gasification processes.
The only process we have found at an industrial scale operating is the ThermoSelect process.
IWT processes municipal solid waste, but that's only the beginning. What else goes in? Everything, including certain things which are particularly harmful when placed in landfills. Worn-out tires, outdated electronics and e-waste, medical waste, car batteries, appliances, styrofoam. We can even process municipal sewage sludge. Those things that have caused nightmares to get rid of become the very things that keep the self-sustaining IWT plant running. Here's how we do it. A crane operator drops waste into a hopper, and a press compacts it, compressing it under tremendous force. This creates an air-free plug. Remember, we avoid air, we avoid combustion. We heat this densely packed plug of waste. The heat begins to break the waste down into steam, some synthesis gas, and a residual char. This combination of gas and char enters our high-temperature chamber, the core of the gasification process. The separation continues as the char drops down and the gases rise. Don't forget, oxygen levels are kept low, ensuring the waste doesn't burn and create toxic emissions. Not incinerated, gasified. The temperature in the lower section of the chamber reaches 3,600 degrees Fahrenheit. This causes molecular dissociation to occur. Harmful pollutants like dioxins and furans are broken down into harmless compounds. The gases move up and exit the high-temperature chamber, but as temperatures drop, harmful pollutants can reform at around 600 degrees. To prevent this potential, we shock cool the gases, reducing their temperature from 2,200 degrees to 160 degrees in milliseconds. This eliminates the possibility for any toxins to reform. The liquids used to clean the gas are processed in the water cleaning system, where the mineral elements are removed and processed. We extract industrial-grade salt, used in steel mills, and zinc concentrate, which is used to rust-proof guardrails. The cooled gases are scrubbed and processed through a system that reclaims sulfuric acid, which is used in metal etching and also as a powerful cleaning agent found in many household products. And here's the point where we create the most valuable resource for our oil-hungry nation: the syngas. An amazing substance, syngas can be used to generate many types of energy. It's a source for fuels used in transportation, clean diesel and cleaner jet fuel. Here's a B-52 burning normal fuel, and here it burns jet fuel made from syngas. Hydrogen will soon be a primary international fuel source, but no one is quite certain where all the hydrogen will come from. Syngas contains about 38% hydrogen, allowing today's municipal buses and tomorrow's automobiles to run cleaner and reduce our dependence on foreign oil. The most important use of syngas? Syngas is a much cleaner source of electricity, reversing pollution created when we burn fossil fuels such as coal and oil. Back in the chamber, the inert material and waste, glasses and metals, are collected in the base of the high-temperature chamber, become molten, and flow by gravity through a homogenizing section to a water-quench bath. This renders any toxins completely non-leachable. This produces a kind of metal shot and a sand-like aggregate. The aggregate is formed in the same way lava becomes rock as it flows into the ocean. These two products are separated by using a magnetized conveyor to extract the metal product, leaving the aggregate, which increases the strength of concrete and can also be used to construct roads. Mixed with asphalts, it produces a durable concrete material used to pave roadways. The alloy comes out in the form of metal pellets and is used to create a variety of metal products, from semi-structural steel to tin cans, dumbbell weights, and tools. The high-temperature gasification process is a revolutionary way to dispose of garbage, transforming waste into resources. So an answer to our problem exists. Our legacy, our promise to our children is kept when our solutions protect their future. The environmental benefits are obvious. Eliminates waste, creates clean energy, no toxic emissions, runs on the energy it creates, no processed water discharges, recycles 100% of the waste into energy and useful products, minimal air emissions when creating electricity, greatly reduces the need for landfills, and therefore the pollution landfills cause. But how soon? Now. Japan currently has 7 ThermoSelect waste processing facilities operating at full capacity, transforming waste into energy and resources. There are economic benefits as well. 1 ton of garbage has the equivalent energy of 1.7 barrels of oil. On a national level, for every ton of waste processed by our system, the U.S. could purchase nearly 2 less barrels of foreign oil. Locally, the plants create long-term, high-paying technical jobs. The construction of each plant employs hundreds of local workers for about 2 years. Predictable disposal costs allow city managers to budget far more effectively. Cost comparisons. Our process, far superior environmentally, is cost competitive with other thermal disposal technologies. And in many cases, we compete with the cost of landfills. Another benefit of this technology? Each plant's output can be customized to meet its community's needs. Electricity, alternative fuel, a combination, all easily done. Dr. Themeles traveled to Japan in order to validate ThermoSelect technology for use in the United States.
My trip to Japan showed me that, in fact, ThermoSelect is working. Japan has worked for years.
The facilities in Japan are proof. New York City, the City of Los Angeles, and separately, the County of Los Angeles evaluated. It improves our environment, reduces oil imports, strengthens our economy, and begins the long-needed change toward independence from fossil fuels. We can't answer every question asked by the future, but we can answer one. Our legacy? Environmentally positive, economically sound, transforming waste into resources.